What's up, guys? Just busy balling it up a little because today we're talking about spheres. This is our next 3D shape we're going to discuss just a little bit. And so, something pretty common that you guys are familiar with is the shape of a sphere, a ball, or our planet. There's many things in this general shape of a sphere. So, basically, some people describe this as like a 3D circle. And that's kind of what it is. So, our definition of a sphere is when we have the set of all points equidistant from a fixed point. Now, you might notice this is very similar to our definition we had for a circle. The only difference we did in a circle is we put the set of all points in a plane equidistant from a fixed point. So if we stuck on a flat surface and I said make every point that's 5 centimeters away from this, we'd end up with this shape going in a circle around here. But if I don't restrict it to a plane, if I just say anywhere 5 centimeters away from a certain point, so let's say our point's here, we could go this way, we could go this way, but we could also go forward or backwards 5 centimeters, or up or down. And so what you end up with is this three-dimensional, constantly curving thing that stays equidistant from that fixed point right at the center of the sphere. So, a little bit of terminology that goes along with this, and it's real similar to the terminology for circles. The distance from that center to the outside of the sphere is called the radius. And we could go sideways, we could go up, we could go down, we could go forward, we could go backwards. Any direction, the distance is constant. Distance from the center to the edge of the sphere is always the radius. If we want to go one side of the sphere to the opposite side of the sphere through the center, we call that the diameter. And so same with a circle, diameter is twice the length of the radius. Basically just a radius and another radius stuck together to make that diameter. Now, formulas for how we find surface area and volume, because that's, if you notice, that's what we've been talking about a lot in this unit. Surface area is 4 times pi times radius squared. And volume is 4/3 pi r cubed. This is kind of a new idea, having to cube a number in one of these. Now, if you're curious about where these come from, there are some good videos, and maybe I'll post a few of them that show where these come from. It's fairly intense, the mathematics involved in where these come from. Really some calculus thinking, but that's the formulas we're going to use to come up with surface area and volume. So we're going to see if we can do this for one. Now, I'm going to do this for a certain particular thing. And so if you notice on this ball right here, we've got 8.5 inches. Now, when it says 8.5 inches on this, it's referring to the diameter. And so the diameter of this ball is 8.5 inches. However, do you notice our formulas both involve r and not d? So that means we're going to have to figure out the radius. So I just took that 8.5 and cut it in half, and I got 4.25 for the radius. So let's see if we can find the surface area of this thing. So surface area is 4 pi r squared. R in this case is 4.25. So we get something like this, 4 times pi times 4.25 squared. And so if you wanted to leave this in terms of pi, you could do that. I'm going to get it as a decimal this time, but you could square that, multiply it by 4, be that number times pi. So when I get that number times pi, in this particular one, I get that the surface area is about 226.98 square inches. Now, that's using the pi button in the calculator to getting 10 digits of pi instead of using 3.14. If you use 3.14, you're going to get something close to this, but you might be off by just a little bit. So there's the surface area of that. Now, as far as application goes, like talking about this ball we were just looking at, the surface area would be how much rubber does it take to cover the surface of this thing. That's what surface area is talking about. Remember, surface area is always talking about covering. How much does it take to cover something? And then volume. Let's see if we can find the volume of this same ball. So volume would be finding something like how much air does it take to fill up this ball? How many cubic inches of air fit inside of that ball? And so this is going to be, using our formula over there for volume, 4/3 times pi times radius. Radius is 4.25, so times 4.25 cubed. All right, now this, I wanted to talk about just a little bit about how to enter this in your calculator. And something I'd really like you guys to do is grab a calculator and try to do this along with me. So you have to pause the video for a second, do that. because the biggest problem that people run into is knowing how to type all this into a calculator to get the right answer. So I'm going to give you a couple options on how you can go about doing that. So 4.25 cubed. We've done a lot with squaring numbers, and most calculators have a squared button. Not all calculators have a cubed button. Most don't. But a lot of calculators have this instead. So if I wanted to do, I'm just going to do some other stuff off to the side here. If I wanted to do 2 cubed, the way that would look in a calculator is something like this. A lot of times is the button you would use. It's a caret, it's called, so it's basically just this like upwards facing arrow looking thing. Some calculators have, if you want this, you have to hit 2, and then there's a button that says x to the y or y to the x power. So you'd hit that, and then 3. It just depends on what calculator you have. Another option would be, you could just type in 2 times 2 times 2. Now this one's easy enough, you could probably like figure that out. 2 times 2 is 4, 4 times 2 is 8. This one's not so easy. I don't know what 4.25 times itself 3 times is off the top of my head. So there's some options for how you could get the cubed part. So once you have this cubed, you need to multiply it by pi and multiply it by 4/3. Now to get the 4/3, some of you guys have calculators with the ABC button, so you could use that. That would be fine. Or you could just do times 4 and then divide it by 3. That's the same thing. Or you could do times and put 4/3 in parentheses. Would all be okay ways to do this. So what I'd like you guys to do, I'm going to put the answer down here, and I want you guys to try to mess around with the calculator for just a second and make sure you get this same answer, whatever way that you're doing it. And so this should end up being about 321.56 cubic inches. Alright, so like I said, take a minute, mess around with that formula, make sure that you have a way that you're typing this in that works for you to come up with that result so that you know you're doing this correctly. Just one little word of caution I want to make on this. Some people have been trying to take these fractions and like round them. It doesn't really work. So 4/3 is about 1.3, but it's really 1.3 repeating forever. So if you just put this in as 1.33 in your calculator, you're going to get something in this neighborhood, but it's going to be off by enough that it is not correct. So we really need to keep that as a fraction, so we're doing 1.3 repeating. I guess technically you could put 1.33 and just hit it a whole bunch of times in your calculator, but a better way is just leave it as 4/3, leave it as that fraction and put it in. Alright, so there's how we find surface area, volume of a sphere, and remember what we're finding with these, because I know we've done surface area and volume separately for all the other shapes. Surface area is how much does it take to cover the outside. Volume is how much fits inside, or how much it takes to fill the shape.